All right, welcome to The Explainer. Today, we're diving into a huge tech mystery, one that involves hundreds of billions of dollars, the world's best hackers, and, weirdly enough, a dog that didn't bark.
So let's start with the money. The AI industry is absolutely exploding. We're talking hundreds of billions of dollars. It's pulling in massive investments, and it's being woven into, well, everything, from how we search the web to our most critical infrastructure.
With that much cash and influence on the table, you'd think it'd be a feeding frenzy for hackers, right? You'd expect a constant storm of attacks. But instead, there's this weird, puzzling silence from the most skilled hackers on the planet.
I mean, think about it. We see headlines all the time about banks getting hit, social media getting taken over, even governments. But you never, ever see these kinds of headlines for an AI itself. And it's not for lack of trying, believe me. The absence of these headlines, that's the clue. This is where we go full Sherlock Holmes. You know the famous story? The solution to the mystery wasn't about what happened, it was about what didn't happen. And to crack this case, we have to start by understanding what we're even looking for.
So first things first, let's get our terms straight. What does it actually mean to hack something?
See, hacking isn't just tricking a system to get a funny answer one time. Real hacking means you're breaking past a security wall to do something permanent. You're stealing data that's stored somewhere, you're taking control for good, or you're changing how that system behaves from now on.
So what are hackers looking for? Well, this is kind of like their shopping list. They're on the hunt for things with persistent memory, valuable data, running code they can hijack, basically anything that holds value and lets them stick around and maintain control.
Okay, so with that shopping list in mind, let's go take a look at the AI model itself. Does it have any of this stuff for a hacker to grab?
And this, right here, is the absolute core of the mystery. It's the huge gap between the AI we see in movies and what a large language model, an LLM, actually is. We picture this conscious being, right, with memories and goals. But the reality? It's a stateless text predictor, and stateless is the key word. It means it literally has no memory of what just happened. Its core programming is completely frozen.
The entire thing, the AI's perfect alibi, boils down to this one simple mathematical proof. Now, don't worry, you don't need to be a math whiz. All this equation really means is that the change in the model's internal state over time is zero. Put simply, nothing inside the AI model ever permanently changes. It can't.
The process is always the same. And the best way to picture this is with an Etch-a-Sketch. Every single time you type in a prompt, the AI computes an answer, shows it to you, and then, poof, it shakes the Etch-a-Sketch completely clean. The entire internal state is destroyed, with absolutely no memory of what just happened.
Okay, so that probably makes you wonder, what about jailbreaking? If the whole thing gets wiped clean every time, how are people tricking it into getting around its safety filters?
Well, here's the thing. Jailbreaking isn't hacking in the true sense of the word. You're not breaking into the system. You're just using a clever combination of words that happens to activate a different pattern in the model's training data. You haven't bypassed security, you've just asked a different question.
One of our sources had a fantastic analogy for this. If you go to a library and ask for a book on explosives, the librarian says no. But then you ask for a book on historical chemistry, and she gives it to you. Did you hack the librarian? Of course not. You just found a different way to ask.
So if the AI model itself has this perfect mathematically proven alibi, where are all these security problems we keep hearing about coming from? Who's the real culprit?
It turns out the target was never the AI model at all. It's all the normal stuff built around it. The login page, the database that stores user info, the API. This whole system is what we call the wrapper. And this is so important to get. Every single time you see a headline about an AI hack, it's really just a totally normal, old-school hack of that wrapper. It's never someone hacking the AI's mind or memory. It's just a regular old database breach or someone stealing user passwords. So this is the critical distinction. Hacking the web application that runs the AI? Totally possible. But hacking the actual core AI model? Impossible. Why? Because there's nothing there to hack. There's no memory to corrupt, no goals to change, no thing to take over. And once you really get that distinction, it completely changes how we should be thinking about AI security and where we should be putting our energy and our resources. What this all means is that our focus probably shouldn't be on these sci-fi scenarios, like protecting an AI's consciousness.
It should be on the real, kind of boring, but absolutely critical work of applying standard, proven security practices like database security and multi-factor authentication to that wrapper application.
You know, at the end of the day, the words we use really matter. As one of our sources points out, calling these simple input tricks hacking just creates a lot of unnecessary fear. It misdirects our security efforts away from the real vulnerabilities and toward imaginary ones.
Which brings us right back to that central clue. The dog didn't bark. The reason AI systems aren't being hacked is because, well, there is no dog. There's no persistent, intelligent AI entity there to be hacked in the first place. And that leaves us with a really important final question to think about. By focusing on these science fiction threats of a hackable AI, are we actually ignoring the very real present-day risks like corporate fraud, market monopolies, and just plain old user deception?